Okay, so yesterday we did 1 and 3, the coterminal. So just a quick refresher, coterminal with degrees, you would add or subtract 360. Coterminal with radians, you would add or subtract 2 pi. And then converting from angle to radian. So if it's in degrees, we multiply times pi over 180, and radians to degrees would be 180 over pi. Number 2 says find the complement and the supplement of pi over 3. So for the complement, what do you do? Good. Take the angle and subtract it from pi over 2, which is the same thing as 90 degrees, which is what a complement would be, right? And then in this case, we've got to change them so they have the same denominator, which would be 6. So this would be 3 pi over 6, and this would be 2 pi over 6. And I end up with pi over 6. So that would be the complement to pi over 3. And then the supplement, the equivalent to 180 degrees is what in radians? Pi. Good. So I would do pi minus pi over 3. This becomes 3 pi over 3 minus pi over 3, or 2 pi over 3. And that's my supplement. So remember, if they're negative, then there would be no complement or no supplement, whatever you were looking for. And then 4 says a circle has a radius of 7 inches. Find the length of the arc intercepted by a central angle of 210 degrees. So what's the equation for arc length? Theta times r, right? And what's important about theta? Has to be in radians. So this 210 on the first thing I'm going to do is convert it to radians by multiplying by 180 over pi, or pi over 180, sorry. Cancel through the zeros, and then 3 goes into both of these, 7 and 6 times. So this would be 7 pi over 6 times the radius, which they give you as 7 inches. And then 7 pi over 6 times 7 is 49 pi over 6, and it gives it to you in terms of inches. You want to leave it as a simplified fraction. So you want it in fraction format, not rounded decimal. And you want to keep pi in your answer instead of using the pi button. Question on either of those?
Why do we multiply it by pi over 108?
Because you got to convert it into radians first, and then plug it into the equation. So the theta in the equation is already converted into radians. So 4.2 is actually called the unit circle. We're going to talk about all the stuff unit circle related today. And then 4.3 is right triangle trig. So we're going to kind of get the overlap after that point. So we started talking about the unit circle yesterday. Okay? We started filling it in a little bit. This is what it would be like if it was completely filled in. So this would be like an answer key for your quiz, minus the positive and negatives on the corners. So the unit circle itself is a circle that has the equation x squared plus y squared equals 1. So if I had given this equation to you and I had asked you to identify the center, what would you tell me? 0, 0, which is where this point is here. That's 0, 0. How about if I had asked you for the radius of that circle? It's 1. So notice that the furthest points out in the 4 directions, up, down, left, and right, are all 1 unit out. So that's why this is the unit circle. The radius would be 1. So then all the points that get filled in between are based on right triangles that have a hypotenuse of 1. So each of those radii become the hypotenuse, and the hypotenuses would all be 1. So because we're doing the unit circle, there's really just 3 special angles we're talking about, which is the 30 degrees. So this is a 30, 60, 90 triangle. The 45 degrees, that would be a 45, 45, 90 triangle. And the 30, 60, or 30, 60, 90 triangle, where the 60 is down here and the 30 is at the top. So all of these points come from the overlap of a right triangle inside the circle with a hypotenuse of 1. Okay? If you remember your unit circle, your right triangles, the special right triangles, 30, 60, 90 is A root 3 and 2A. And then a 45, 45, 90 triangle is A, and A root 2. If we took and filled in those hypotenuses as the ones and then found all the other side lengths and used SOHCAHTOA to find sine and cosine, those points are what form these points around the unit circle, okay? So for right now, we don't have to worry about actually deriving them. Just know that that's where they come from. They're not like made up numbers that somebody just plotted a point and said that this makes sense. These would be the result of a 30, 60, 90 triangle with a hypotenuse of 1. And then a 45, 45, 90 triangle with a hypotenuse of 1. And then a 60, 30, 90 triangle with a hypotenuse of 1. That's where they come from. But we want to memorize it because, again, we're going to memorize it to then apply it. So I want you to go back to your unit circle that we started yesterday. And we're going to fill it in again. So if you want to do it digitally, you can. If not, you can take out the hard copy I gave you. Again, this is exactly what your quiz will look like. So we can start with what we talked about yesterday. So quick review of angle measurements. Start with the quadrant angles and in degrees. This is 0. At the top would be what? 90 on the left. 180, that's my straight line. Halfway between the 180 and the 360 is 270. And then all the way back around on the right is your 360. So those are your degree measurements for your quadrant angles. And then we said the pattern for the rest of the angles is what? 30, 15, 15, 90. So to the 0, I would add 30. To the 30, I would add 15. Add 15 again. And then 30 brings me to the 90, which is already there. And then repeat that process again. So then 30 added on to the 90 is 120. 15 would be 135. 15 is 150. And then 30 is your 180. That's already there. Repeat it again. 180 plus 30 is 210. 210 plus 15 is 225. 225 plus 15 is 240. 30 would be 270. And then one last time, 270 plus 30 is 300. 300 plus 15 is 315. 315 plus 15 is 330. And 330 plus 30 is 360. So now I've got all of my degree measurements there. And then we went back in and filled in our radians. So if it is 0 degrees, it is how many radians? 0. If it's 90 degrees, it's how many radians? Pi over 2, or 1/2 pi. Because if it's 180 degrees, it's how many radians? Pi. And then halfway between the pi and the 2 pi would be the 3 pi over 2, or 1.5 pi. And this finishes up with 2 pi, which is one circle all the way around, circumference with a radius of 1. And then we said there's a pattern for the other angles. What's closest to the x-axis? Over 6. So all of these are over 6. Closest to the y-axis is over 3. And then the in-between, over 4. They all get pi. So pi goes all the way around. And the first quadrant gets left how it is. So pi over 6 is the equivalent of 30 degrees. Pi over 4 is the equivalent of 45. And pi over 3 is the equivalent of 60. What's the pattern for the second quadrant? Numerator is 1 less than the denominator. So this is 2 pi over 3, 3 pi over 4, and 5 pi over 6. Third quadrant is 1 more. So this is 7 pi over 6, 5 pi over 4, and 4 pi over 3. And the fourth quadrant? 1 less than double, or 5, 7, 11. Okay, that's where we left off yesterday. Again, about 2/3 your way through. Questions so far? Okay, so now if you could remember the next couple of things, not only will it make your unit circle easy, but it will continue to pay off as we move forward within the chapter and then continue with inverse functions and all of it, okay? Every over 6 has the coordinate of √3 over 2 and 1/2. The positive and negative signs are going to change, but the two coordinates will always be that. If it is over 6, it is root 3 over 2 and 1/2. Every over 3 is the reverse of that, 1/2 and root 3 over 2. Again, we're going to adjust the positive and negative signs, but the actual coordinates will always be those. And then every over 4 is root 2 over 2 and root 2 over 2. If you can memorize those 3, your life will be made so much easier. And again, if you wanted to draw out your right triangle, 30, 60, 90 triangle with a radius of 1 and figure out your missing sides and work your way from SOHCAHTOA backwards, you would get the same coordinate points. So now I'm going to fill in all those ones around the unit circle. So all the over 6s are root 3 over 2 and 1/2. All the over 4s are root 2 over 2 and root 2 over 2. And all the over 3s are 1/2 and root 3 over 2. Now think about the positive and negative signs as you move through a quadrant, right? In the first quadrant, what's true about the X's and the Y's?
Positive.
They are both positive. So I'm going to leave them alone. How about in your second quadrant? The X is negative, the Y is positive. So all of these X's are going to get a negative sign. You need to write it in the corner and also adjust your point. How about the third quadrant? They're both negative. And in the fourth quadrant, X is positive, Y is negative. Now, eventually, we're going to start talking about those positive and negatives in terms of sine and cosine, but for today and for your quiz on Thursday, you can give it to me in terms of X and Y. All right, then the only thing we've got is actually what defines the unit circle, which are the 4 quadrant points. We move to the right one and not up or down at all there. We don't move left or right at all. We move up 1. We move left 1 and don't go up at all. And we move down 1 and don't go left or right at all. There's tons of other little nuances to remembering this. There's little tricks, okay? So you don't have to know it the way I know it. As long as you fill it out, I don't care how you know it. And if you go on the iTunes U course, there's kids from previous school years had come up with tricks and made their own little videos. So they're on there too. There's, patterns of 3, 2, 1 with the points, 3, 2, 1, 1, 2, 3, all the way around, that kind of thing. And then with your radians, there's your 6, 4, 3, 2, 3, 4, 6, all the way around, so you can do it that way too. I don't care how you know it, as long as you know it, okay? So now let's talk about what all that stuff means. So this kind of talks about what we had just said before, where if that radius is 1, that's where this unit circle is formed by, okay? The intercepted arc is the radian measure of that central angle. We talked about that yesterday. This is what's more important. So the 6 trig functions that we're going to focus on are sine, cosine, tangent, cosecant, secant, and cotangent, okay? You can abbreviate them so you don't have to spell them all the way out. Sine is S-I-N, cosine is C-O-S, tangent is T-A-N, and then cosecant is C-S-C, secant is S-E-C, and cotangent is C-O-T. So there are two ways to get sine and cosine. One is from a right triangle, which is what 4, 3 does. For this section, you're learning how to get it from your points in your unit circle. The sine comes from the y coordinate of your unit circle. So whatever that y coordinate is that matches the angle that you're given is your sine. The cosine is your x, and the tangent is your y over your x. It says x can't equal 0 because otherwise it would be undefined there. That's what that means. And then the other three are reciprocals of the first one. And if you have a hard time remembering, remember the c's and the s can't go together. So if it started with an s as in sine, then it gets the c as in cosecant. If it starts as the cosine with the c, then it goes to secant. And then cotangent and tangent literally both have the same word in them. So hopefully you remember that one. So if I take and flip sine, I get cosecant. If I flip cosine, I get secant. And if I flip tangent, I get cotangent. So all of these come from knowing the x and y points along your circle. So this first, we're going to baby step our way in. It says, use the figure at the right to find the trig functions at t. So this one's already giving you the point. T is the angle. So you want to find the sine at t. You want to find the cosine at t. You want to find the tangent at t. And then the cosecant, secant, and cotangent. So which coordinate did we just say was sine? The y, which would be root 3 over 2. Cosine is which coordinate? The x, which is 1/2. Tangent is the y over the x. So root 3 over 2 over 1/2, and I keep flip that, and I get root 3. And then take each of them and flip them upside down. So the cosecant becomes 2 over root 3. Can I leave it like that? No, you got to rationalize it. So you multiply both the top and the bottom by root 3. And I get 2 root 3 over 3. Secant, I flip cosine. 1 over 2 becomes 2 over 1. And tangent, that's root 3 over 1. So that becomes 1 over root 3, which again gets rationalized. And I get root 3 over 3. Easy stuff, right? Biggest mistakes come from the memorization part of the points and then also switching the x and the y. Other than that, hopefully this stuff is pretty easy. And the more well you know that unit circle, the easier this will be for you. Okay, now it says find the point xy on the unit circle that corresponds to the real number t. So it's giving you the angle and it wants the coordinate. So this is, again, this is where it depends on how well you know this. Anything that's over 3 would be what point? Try to do it without picturing your unit circle. We said every over 3 is what?
Over 6.
1/2 and root 3 over 2. So already I'm halfway there. I already know the coordinate, right? I got some partial credit whether or not I know what positive or negative sign it is just by knowing every over 3. So then the fact that it's 2 pi over 3, you can again picture your unit circle. The number in the top is 1 less than the one in the bottom. What quadrant does that happen in? Second quadrant. What sign is positive and what's negative in the second quadrant? X is negative, y is positive. So even without knowing, like seeing your unit circle in front of you, hopefully you get to know it so well that you could do that stuff. The other way to picture it is, let's say that this is not, you don't know exactly where it is in the unit circle. I know 2/3 is bigger than 1/2, but less than 1, right? And anything bigger than 1/2 and less than 1 is in my second quadrant. All right, so now you're putting both those things together. It's asking you to figure out what's the point at that angle and then just find sine, cosine, and tangent for each one. So I'll do A with you since we just kind of started it. We said that 2/3 pi was negative 1/2 and root 3 over 2, which means my sine is root 3 over 2, cosine is negative 1/2, and tangent would be root 3 over 2 over negative 1/2. Flip, and I get negative root 3. So identify what's the point at that angle, and then from there, find your sine, your cosine, and your tangent. All right, so if you look at B, negative pi over 3, again, I've got an over 3, which tells me my point is that 1/2 root 3 over 2. Negative pi over 3 falls in which quadrant? Fourth quadrant. So there's two ways to look at it. One is work my way down to the first pi over 3, which would be negative pi over 3 there. Or you can plot it as though it's positive pi over 3, which we know to be here, and then reflect it over your x-axis. So fold it in half and it overlaps where it should be. So whichever way you look at negatives is up to you. Just make sure you understand how to do one of those ways. So that tells me that my x is positive, but my y is negative. So sine is negative root 3 over 2. Cosine is positive 1/2. Tangent y over x. Keep change flip. And again, negative root 3. Questions on that one? Okay. Then I go to C. Now this is an over 3, but this is an exception to my rule. Why? It's actually able to be reduced, right? So 6 over 3 becomes what? 2 pi. So you want to reduce it before you figure out what the point is, because 2 pi, we know where it is, right? It's right here on the right-hand side. That point is 1, 0. My sine is 0. My cosine is 1. And my tangent would be 0 over 1, which is 0. Questions on any of those? All right, domain and range of sine and cosine. So if you remember your little graphs of sine and cosine from Algebra 2, okay, what you should remember is that they are unending. They're going to continue on from left to right. So we're going to learn more about that as we get to the end of the chapter. But if you remember that, if I looked at my x values, which is my domain, they don't end, which means that the domain and range, the domain of sine and cosine are all real numbers, or negative infinity to positive infinity. But if you also remember that the range is bottom to top, your standard sine and cosine functions never go above 1 or below negative 1, which means the range would be from negative 1 to positive 1 inclusive, which means it can include negative 1 and positive 1. And sine and cosine are periodic, which means that the functions behave in a repetitive or cyclic manner. That means that every time I go around my circle, from my initial angle to every other coterminal angle, I'm going to have the same point. So whether my point is at, let's say, 2 pi or 8 pi, that means I'm going around the circle. That would be 4 pi. That would be 6 pi. That would be 8 pi. Still results in the same spot. So those are coterminal angles, and coterminal angles will have the same x and y coordinates. So now we're saying evaluate the trig function using period as its aid, meaning these are not going to be on your standard unit circle, but they are coterminal to one of those points. You just got to figure out where they're at. So if I look at 13 pi over 6 and I convert that into a mixed number, what's 13 over 6? 2 and 1/6. So this is like 2 and pi over 6, right? Or 2 and 1/6 pi. The rule for whole numbers is that the odd whole numbers are on the left and the even whole numbers are on the right. So I could go all the way around my circle to 2 pi, or I would know that 2 is even, which means start out on the right and go to the first pi over 6 I hit, which is in my first quadrant. I know it's over 6, which means my point is root 3 over 2 and 1/2. And now I know that point lies in the first quadrant, which means they're both positive. And the sign would be 1/2. So I'm only looking for one trig function. For 5 pi, again, you could picture it. 5 pi, I would start here. This is 1 pi, this is 2 pi, this is 3 pi, this is 4 pi, this is 5 pi. And that point is negative 1, 0, making my cosine negative 1. Or you can just remember that odd whole numbers fall on the left. Even on the right, odd on the left. Makes your life a lot easier. questions on that so far?